Welcome to the 19th Century Charitable Association of Oak Park, where it is our vision to be a dynamic cultural center for community learning. Good afternoon. I am Judy Boker, member of the Science Committee responsible for today's presentation. We have scheduled 30 programs for this season of our enrichment series as part of our mission to strengthen our community through learning, giving, sharing our landmark building. Today's program is A World Apart, Mammalian Biodiversity in the Philippine Islands. I'm so pleased to introduce our speaker today, Lawrence Heaney, PhD. Larry first became interested in nature and mammalian research when he volunteered as a teenager at the Smithsonian Museum of Natural History in Washington. Larry received his undergraduate degree from the University of Minnesota and his PhD from the University of Kansas. He now works at the Field Museum as a curator of animals, and he also teaches students at the University of Chicago and in the Philippines. Since 1981, he has spent several weeks a year in the Philippines doing mammal research with Filipino scientists and teaching students. They have discovered 50 species of animals that were previously unknown. Let us welcome our speaker, Dr. Lawrence Heaney.
Great pleasure to be here. I'm a research biologist working at the Field Museum. People are familiar with the museum mostly because of the public programs, the exhibits, that kind of thing. That's more or less half of what goes on at the museum. The other half is essentially a biological diversity research center. People working all over the world on plants and animals, and dealing with a variety of, cultural kinds of issues as well. Makes it a very interesting place to work. As Judy mentioned, I got started very early in life with an interest in nature. Spent a lot of time wandering around in the woods and playing in the creek. And when I found ways to follow through on my interests early in life, I took advantage of them. That eventually turned into an interest in Southeast Asia, and in particular on evolution of animals on islands. So you're probably familiar with the kind of work that people have done for centuries now in the Galapagos and Madagascar and many, many other island groups around the world. I've chosen to work in the Philippines in part because it is a very large set of islands. Officially, the government claims, I believe, 7,700 islands. The largest of them are only a little bit smaller than Cuba. So the largest of them are very, very large islands. We'll talk more about that. So let's see. Okay, so beautiful country, spectacular. If you get a chance to go there, try to not spend all of your time in Manila. Try to get out into the countryside. Spectacular. Part of what makes it interesting is that the islands are all more or less volcanic in origin. And the kind of view that you see here is representative of what you can see when you get up high in the mountains on a relatively clear day. So the three mountains that you see there are all volcanic in origin. The one in the middle is one of the most active volcanoes on Earth currently. This is Mount Mayon, more or less constantly in eruption. Not major eruptions, but very, very active. The one to the left of that is one that underwent one of the major explosive eruptions. This was thousands of years ago. long before there was recorded history. But there have been repeated, of course, major eruptions of that sort over time, and we'll talk about one of those. I need to say at the outset that I will use at times the word we. That's not a royal we. That means we. Lots of people have been involved in this project over time. I started working in the Philippines in 1981, doing field work there, studying biological diversity, and have been extremely fortunate to work with people from lots of universities, lots of conservation organizations, lots of government agencies, museums, the full range. And it's been absolutely wonderful. It's been a team effort all the way along. So unfortunately, of course, I don't have time to even name the institutions, much less the people who've contributed. But please bear in mind, this has been a group effort. Okay, so why the Philippines? Well, this is somewhat out-of-date information now that will give you a rough idea. So the point of reference that people often use for thinking about biodiversity is the Amazon, Brazil. Tremendous amount of diversity there. For the land-living native species, things that weren't brought in artificially by humans, for land mammals, so we're not including whales and porpoises and things of that sort. In 2004, we knew of 183 species in the Philippines. I'll come back to that in a little bit. Breeding land birds, just a little bit short of 400. Reptiles, 258 species. Amphibians, 101. For a total of well over 900 species of land-living native vertebrates. So, how does that compare to Brazil? Well, Brazil has over 3,000, so more than 3 times as many species as the Philippines. Clearly, much more biological diversity there. If we look only at the species that occur only within the named country, so what the term that biologists use is endemic, so things that are native and live nowhere else. The total for the Philippines at the time was 563, for Brazil 788. Not nearly such a disparity between the two. One of the biggest differences that you see immediately is that 60% of the species at the time that were known in the Philippines occurred nowhere else in the world. In Brazil, 28%. A lot, but a much lower percentage. Brazil is 28 times larger. The Philippines, so far as we know now, as a country, has the richest mammal fauna, unique mammal fauna of any country. So the research that I and my collaborators have done over the years has essentially been oriented toward asking and trying to answer one very simple question. Why? What is it about the Philippines that makes it so distinctive, so unique? Now, you might say that, comparing the Philippines to Brazil maybe in a sense is a little bit unfair because it is 28 times larger. What about Spain? Spain is roughly the same land area as the Philippines. Well, there are a total of 435 species of land-living vertebrates, compared to the 938 that were known in the Philippines at the time. Far fewer. So, for most countries that are relatively large, relatively diverse biologically, as Spain certainly is, it is pretty typical for not more than about 6% of the species to live only within that country. Keep that point in mind. We'll come back to it. Okay, so familiar map of Southeast Asia. So I think I can do this. All right, so here, extending across much of the area is Indonesia. Australia down here to the south. There's the Philippines up there. Malaysia extends across from the Malay Peninsula, which is connected to continental Southeast Asia. And then the northern part of the island of Borneo is part of Malaysia also. So those are the primary countries in that part of the world. You can see from this that the Philippines is, it's out there on the edge of that. It's fairly isolated. Pretty big islands, not as big as some of the ones in the area. It's a political map. From a perspective of biology, it's not the most meaningful way to present the geography of the area. This is more helpful, more informative. So this is a map that shows the extent of land area during the last glacial episode. So you're probably all familiar with the fact that, say, 12,000 years ago, this area right here in Chicago, or Oak Park, would have been covered by somewhere between half a mile and a mile of ice. The water that formed those continental glaciers, of course, came from the oceans. Water would evaporate from the surface of the ocean, be carried over land, and during these periods of low temperatures would be deposited on land as snow. Over the course of thousands of years, the snow built up, compacted down, and began to form continental glaciers. As the continental glaciers formed, of course, water was being removed from the sea. And so as the glaciers built up, sea level went down. All right, that hit its peak most recently about 12,000 years ago. And at that stage, sea level was about 400 feet lower than it is today. About 120 meters lower. Well, the result of that was that large areas that today are part of the South China Sea were dry land. In fact, with a radar type of system, you can actually still see the river channels cut on the bottom of what's now water that's 200 to 300 feet deep. Now, the edge of the continental shelf here, these shallow areas, runs around here, runs between Bali and Lombok, which you may have heard about if you read about biological diversity. Anyway, and then cuts between Borneo and the island of Sulawesi. This is all part of Indonesia. That continues on up around the edge of Borneo. And you can see then that the Philippines are cut off away from the continental areas by a series of deep sea channels that never dried out. That's key for studies of biodiversity in this part of the world. And even within the Philippines, you may be able to see that, yeah, there's some channels that remained seawater even during that low period. Well, here's a more detailed map of that. So, in the north is the big island of Luzon. Manila Bay is, well, the bay that's right up there. So, big island extending down here. During that period of low sea level, it expanded out somewhat, absorbed some of the adjacent islands to form what's known as, excuse me, Greater Luzon. Mindoro, an island that's just off the coast of Luzon, stayed isolated. Narrow sea channel, but isolated. In the south, the big island of Mindanao expanded out to include islands that are currently isolated. So this is Leyte Island here, Samar, and lots of others. Here in the central part of the Philippines, again, there was some merging of islands into a bigger one known as Greater Negros Panay, Over here, the island of Palawan also expanded out, but didn't connect up to the other large land areas. And there were little islands that remained isolated. So Sibuyan up here is an example. Camigan, Siquijor, lots of others scattered around. Well, for somebody interested in island biogeography, this is perfect. This is the place to be. All right, so we'll come back to a number of these points. So what are the animals that we have studied? Philippines has a huge fauna of bats, fabulous animals. The one in the lower left corner is a golden-crowned flying fox. If you go to Subic Bay, what was for a long time a U.S. Navy base, you can go see these yourself. They have a wingspan of about that. By weight, they probably are the heaviest, biggest bats in the world. They eat small children. No. Figs. They love figs. So, fruit. Other groups of bats, there's a tremendous diversity. These are different families of bats that are being shown here. Most of them eat insects, but there are a bunch that eat fruit. They range in size from the big one to, well, you see this little guy right there? Those are proportional. So if you go to Subic Bay and you see the big ones, in the evening you will notice some moths fluttering around. They're not moths, those are bats. The smallest of them is called the lesser flat-headed bamboo bat. They are so tiny that, well, you know when bamboo gets old and dries out, it develops cracks. They can crawl through the cracks and roost inside the hollow space in the bamboo. They eat mosquitoes and, tiny little insects. Okay, so fabulous set of animals. There's a limit to how much time. I'd love to spend the next couple of days talking with you about bats. Not going to do that. We're going to move on to talking about the mammals that cannot fly. Okay, so the technical term is non-volant. That means they can't fly. So this is a map that shows patterns of endemism. Endemism refers to animals that occur, or plants, organisms that live only in some specified geographic area. So non-flying mammals in the Philippines that live nowhere else in the world. Okay, I'm going to start with Luzon up there. So this Ice Age island of Greater Luzon, 93% of them live nowhere else in the world, not even elsewhere in the Philippines. And that's 93% of 56 species. That's a lot of species of mammals, and that does not include the 70 or so bats that are on the island. That's an enormous level of unique biological diversity. Right there is a narrow sea channel that separates Greater Luzon from the northern stretch of Greater Mindanao. 93% of the mammal species that occur in this area occur nowhere else in the world. The transition from that point to that point is one of the most abrupt biological transitions anywhere in the world. Smaller islands like Mindoro have fewer than Luzon, so 16, but 75% occur nowhere else in the world. Even little islands like Lubang up here, 3 out of the 5, 60%, live only on that one island. Well, what we can see is that on each one of these islands that remained separated from the others continuously, every one of them is a unique center of biological diversity. So this little island here, Sibuyan Island has 5 species of native non-flying mammals. It's a small island, 4 of which live nowhere else in the world. There's a bat that occurs there also. So the total number of unique species on that one little island, it's 22 kilometers in diameter. It's basically round. So that's about 15 miles in diameter. There are more unique species of mammals on that one island than in any comparable area anywhere else in the world. So, when my colleagues and I talk to people in the Philippines, to the general public, about biological diversity and mammalian diversity in particular, because that's what we have a lot of data on, we refer to the Philippines as the Galapagos times 25. Okay, so, very exciting for a biologist anyway. How do we get these data? Well, lots and lots and lots of field work. So just some photographs to give you a sense of what's involved. Typically, what it means for me is to fly to Manila, meet up with my research collaborators from the National Museum or the University of the Philippines or conservation organizations, whatever. Meet up in Manila and then travel to the capital of the province where we're going to be working, where we spend several days getting permits, working with people, getting things set up. We then take a bus out to the base of the mountain where we want to work, and from there we hire essentially a jeep to carry us and our stuff to the furthest village inn that you can reach by road. And in the village, then, we hire anywhere from 15 to 30 porters to help us carry our stuff up onto the mountain. We then spend, anywhere from a couple of weeks to a couple of months up on the mountain doing our survey work. And then we turn it all around and come back out. It's exciting, it's fun, it's pretty basic. If you love this kind of work, you love it. If you're not into it, it can be really unpleasant. We live in tents. It rains a lot. And so most of the time we have to put the tents up on platforms that we build by hand to keep them off the ground. Otherwise, they fill up with water, which is, you don't want to do that in the middle of the night. So let's see, the green tarp that you see there is our lab. The blue tarp is the kitchen. That's pretty much the camp. So we'll be in a place like that for anywhere from a couple of weeks to a month. And then do the same thing again at a different place on the mountain. Wonderful animals. Absolutely fabulous. This is one of my favorites. It's a member of a group, we'll talk about it in just a moment. People who, mammalogists who look at this say, well, what is that? It looks kind of like a lemur, or maybe a giant squirrel, or what is that? Well, so you're familiar with the fact that there's a group of finches in the Galapagos Islands that are descended from a single colonizing species millions of years ago. They've diversified there over time. Why finches? Well, because they got there. They got lucky. And once they got there, because there weren't many others that were getting lucky, they were able to diversify, to become a more complex community of species. In Madagascar, the lemurs got there and diversified. Same kind of story all over the world. Well, the most diverse group of mammals globally are rodents. And so it should come as no surprise that in the Philippines it happened to be rodents that got there first. So this is an animal that is called a bushy-tailed giant cloud rat. It's big, has a bushy tail, and they live in cloud forest. And it's distantly related to rats. They live up in the trees. They eat only plant material. They have one baby per year. And they live probably in the wild for 8 to 12, maybe 15 years. Really a fabulous animal. They are part of a group generally known as cloud rats. So this is a set of drawings that show the major groupings of the different cloud rats, all descended from a single ancestral species that has diversified. So here's the one that I was holding. Others range in size from, well, a little smaller than a gray squirrel, head and body length, to the biggest ones that are down in the bottom right there. That species get up to 2.7 kilos, which is about 4 pounds, I think. So, small house cat. Pretty good-sized animal. And then there's the other one. So these are all, the two big ones were the first ones to become known to outsiders. And they were referred to as giant cloud rats. Over time, the two kind of in the middle there were discovered. They're smaller animals, so, small gray squirrel, something like that. They came to be referred to informally as dwarf giant cloud rats. Well, some years later, our team, see that little guy up there? Up in the upper right-hand corner? That's proportional to size. Head and body length is about like that. So in the scientific classification system, we use two names for a given species, the genus and the species. So a dog or a wolf, let's say, is Canis lupus. Lupus is the species, Canis is the genus. Canis includes coyotes, dogs, jackals, lots of related canids. Okay, so this is a new genus that we now know contains at least 4 species. It is tiny. And so, of course, it is a micro-dwarf giant cloud rat. These things all live up in cloud forest, up high elevation. They eat nothing but plant material. The big ones are eating bamboo shoots and things like that, buds. The little guys eat seeds. And all of these occur together in one place on many of the mountains in the northern part of Luzon Island. So there has been, from a single colonizing ancestor, this great diversity that has developed. Okay, now there's a second group. Later on, a second ancestral lineage arrived and diversified. In this case, again, 5 different genera, at least 40 species that have developed over time from that original single species. And they all eat earthworms. They love earthworms, some of which are iridescent blue. That's my hand. And they're big. So they're specialized on an unusual food resource. You get up into the high elevation habitats there, and there are layers of humus that can be anywhere from, a few inches to 3 or 4 feet thick, partially decomposed plant material. It's too cold and too wet for termites to live up there, which in the lowland tropics are the primary organisms that consume dead plant material. There are no termites up there. So this humus just builds up. Earthworms love it. Extremely abundant in these habitats. These animals have evolved to take advantage of that unique resource. Each one of these 5 major groupings feeds on earthworms in a different way. Some of them hop around on the surface of the ground looking for ones that are up on the surface of the ground. Others kind of dig around in the surface of the leaves. Some of them dig quite a bit, not quite like a pocket gopher or something like that, but they find their food mostly by digging it out. They're dividing up the niche in a variety of ways. Okay, so how long does it take for this to develop? What's the process? Well, fortunately, using now DNA-based technology, I won't go into the details, we're able to determine that the common ancestor of the cloud rat group arrived about 14 or 15 million years ago from the Asian mainland. And it has been diversifying ever since. The earthworm mice, their common ancestor, arrived a lot more recently. Whoops, we lost the scale down here. But it's about, somewhere around 8 million years ago when they began to diversify. So it's a long, slow process. So one of the reasons why the Philippines has so many unique species is that the islands are old. There has been time for these processes to take place. It's a 100,000 year to often million year process. It does not happen quickly. So what did the Philippines look like at the time? Well, this is just one map that shows the Philippines as it looked about 10 million years ago. So the areas that are shown in green, and here you can see, the Asian mainland extending down from the upper left corner here down to what is today Borneo, and then a series of strictly oceanic islands off further to the east. Some of those are in modern-day Indonesia. Many of them, though, are there in modern-day Philippines. There were only a couple of islands 10 million years ago. Those were pretty big islands, as oceanic islands go. Big enough that they could harbor a fair amount of mammal diversity. The oldest part of Luzon Island, the big island in the north of the Philippines, where Manila is located, has been continuously above water, parts of it, for about 28 million years. The oldest islands in the Hawaiian Islands are 5 million years old. So why are there fewer unique species of mammals in the Hawaiian Islands? Well, one of the reasons is they're just not old enough. They haven't had the time to develop the diversity. Insects diversify a lot more rapidly. They have much more rapid turnover in the population. So they have had time to diversify in a way that the mammals have not. So the timing is crucial. Another aspect for the Philippines is the fact that it's tropical. It lies entirely within the tropics. And as part of that, there's a lot of variation along the elevational gradient, from lowlands to the tops of the mountains. The highest mountains in the Philippines are about 3,000 meters, about 10,000 feet. So pretty high, but not like the Himalayas. But there's a lot of variation along that. And I won't go into the details, but roughly what we see is that in the lowland areas, daytime temperatures, high temperatures of 85, maybe up to 90 are pretty typical. As you go up in elevation, everywhere around the world, as you go up in elevation, temperature declines. If you go from Denver to the top of Pikes Peak, it's a lot colder at the top of Pikes Peak. All right, that happens on a very regular basis. It's 6 degrees centigrade per 1,000 meters. Whatever. It's a very, very regular process, and that's what's shown in the graph up there on the upper left. Okay, now, as air cools, its ability to hold moisture declines. So as the air cools, you get condensation and clouds form. Right? You see that out in the Rockies. If you're driving across the Great Plains and the Rockies are off in the distance, you often see first the clouds at the tops of the mountains. Okay, same thing in the Philippines, except that the air is a lot more humid to begin with. So in the lowlands in the Philippines, average, in many parts of the country, average rainfall in the lowlands is about 2 meters per year. It's about twice what we get in Chicago. Up toward the peaks of the mountains, you could get 4, 5, and 6 meters of rain per year. It is really wet up there. So there's a lot of habitat diversity that's associated with these volcanic peaks. The mountains are isolated from one another. They form groups of islands. Groups of mountains that essentially form high elevation islands. So you've got islands within islands. Now, here's a habitat showing you what I described a few minutes ago. This is mossy forest. It's fabulous. It's just absolutely fabulous. This is where the humus layers can build up to be 3, 4, 5 feet thick. There are epiphytes, ferns, moss, Dieffenbachia, begonia, a lot of the house plants that we have. Are these things that grow on the branches of the trees. It's so wet up there that there's water everywhere. If you stand in a place like this and you've got a big drum of water and you tip it over, all of the water immediately goes into the soil. It's a huge sponge. That sponge releases water gradually over the course of the year, and that's what provides the water for the rivers that all human activities are so heavily dependent on. It's just fabulous habitat, as long as you don't mind getting wet. Okay, so we think about what I was taught in school was that maximum biological diversity occurs in lowland tropical forest. That's half right. Yes, there are many groups of organisms that are most abundant in the lowlands. Among insects, termites and ants definitely are most abundant in the lowlands. As you go up in elevation, as it gets colder and colder and wetter, they drop out and the termites disappear entirely. Well, what about the mammals? So 2 different patterns here. So here's one of these groups of insect-eating bats shown here. And you can see, maybe you can't. Anyway, the dots are at the bottom end of the graph, the lower part of the graph. So the second line cutting across is 1,000 meters, so about 3,000 feet. Most of the bat species are known only from the lowland areas. And as you go up higher and higher, there are fewer and fewer species of bats. That's kind of the overall pattern that we've been led to expect. On the right is the pattern for earthworm mice. There are very few earthworms in the lowlands. There just isn't much there for them to eat, and there are too many predators going after them. The ants especially are ferocious predators of earthworms. As you go up in elevation, the number of species above about 3,000 feet, about 1,000 meters, increases steadily. This pattern of increasing diversity at high elevation is what we are now recognizing as a very common pattern. Why didn't we know about that before? Because nobody looked. This can be a real problem. Okay, so to put some of this together, in the year 2000, we were sitting around a campfire saying, okay, we know that in this big mountain chain in the northwestern part of Luzon Island, there are 10 species of mammals that occur nowhere else in the world. And then there are these other places where, that mountain range off to the east, there are 2 species that we know of that live only there. Down here, there's only 1 that we know of that lives only in this area, and there are 3 down here. And what about this mountain? And what about these and that one? And I mean, why? This is kind of a strange pattern. Why are there some places and none anywhere else? And there doesn't seem to be a reliable pattern. So we started doing field work, based on the observation that when we asked, well, how much do we know about, for example, the mammals that occur on this mountain? The answer was nothing. Nobody had ever looked. Well, so we began looking and did intensive surveys of mammals along elevational gradients, an effort to try to document the whole mammal fauna all over Luzon Island. It's a big island. Again, it's about the same size as Cuba. So very intensive effort. Over the course of those years, it was roughly 40 team months up in the mountains. That's a lot of field work. The result of that was that, well, you can see in that upper graph, starting in 1880, when there was only 1 native mammal known from Luzon Island, the number of species accumulated pretty gradually as sporadic field work was done. When we started in 2000, so right there were 28 species known. Over the course of the next 12 years, we discovered 28 more. So you might say, well, these are mice. They all look alike. Well, there are drawings of what these things look like down there on the right. And hopefully you can see enough of that to get an idea that there's a lot of diversity in anatomy and appearance among these animals. This animal is the micro-dwarf giant cloud rat that we discovered. That's my hand, so you can get an idea of just how tiny that little mouse is. So it's not just, another mouse. It's like, holy cow. The whiskers on that animal on me would come out proportionately to here. They live up in the cloud forest. It's dark and it's foggy up there at night. You can't see much of anything. They find their way around in the forest canopy with this penumbra of whiskers around their head. They have whiskers coming off of their wrist proportionately about that long. They're really different. They're really cool. Okay, so over the course of time, what we found was here, starting at 2000, going to, at this point, this was 2011, the numbers changed dramatically. So this one mountain that I pointed out here, like, why don't we know about there being endemic mammals there? Yeah, 4 of them, nowhere else in the world. 6 down here now. 2 there, 4 there. That number up there went from 2 to 7, from 10 to 14, from 1 to 6. Everywhere we looked, we found previously unknown species previously unknown to science. And often the local people who are working with us would scratch their heads and say, I never saw one of those before. They're small, they're inconspicuous, they're an important part of the ecosystem. And it tells a story. So, okay, so why? Well, part of the reason is, as I mentioned, Luzon is large. 103,000 square kilometers. It is the 2nd largest purely oceanic island in the world. Oceanic islands are ones that have never been connected to, by dry land, to a continental area. The 2nd largest. It's old, 27, 28 million years old. continuously. The first volcanoes erupted in that area probably 35, maybe even 40 million years ago. So there have been islands there popping up and then eroding down for much longer than there has been continuous dry land there. And the result of that is that Luzon has the world's second greatest concentration of unique mammals. The only island with a higher concentration per unit area is Sulawesi, also known as Celebes, the island in Indonesia immediately to the south, for exactly the same reasons. It's just a little bit bigger. Well, okay, all right, that's the fun part. Yeah, so like most countries in the tropics and many elsewhere, there have been lots of challenges to the environment. Logging was a very big thing for a long time. One of the ways that Ferdinand Marcos, the first one, his son is in office again now, one of the ways that he stayed in power was to give logging concessions to his supporters. Lots and lots and lots of unmanaged logging, very destructive, big problems. Erosion was a huge problem, tremendous amount of damage. The bottom photograph shows the result of a flood in an area that had just been logged over shortly after we did field work there. 7,000 people died in about 15 minutes. Well, okay, so, we could talk about that for a long time. I want to talk just a little bit about how I and my collaborators have responded to the problems that we have become aware of. One is by publicizing our discoveries. People get really excited when they hear that there's something unique in their backyard. They like that. Gets lots of attention, provides a spark for conservation activities. That has often happened with the work that we as a big group have done. There have been no field guides to the mammals of the Philippines. None. Zero. Zip. So we wrote one. It's only for Luzon. That's only part of the country, but it's where there are more people there than anywhere else in the country, and it's where most of the economic clout is, so good place to publicize. That's now being used as a textbook at a lot of schools in the Philippines. We've also produced a large number of posters that use the illustrations that have been made by one of the members of our group to get them out to schools, to conservation groups, and so on. We typically have 500 or so printed up ourselves, and then we give copies of the PDF to anybody who wants it so that they can make more copies and distribute them widely. The schools absolutely love these things. Again, there has been almost nothing available in the past, and this really makes a big difference. One of the things that we've found is that when we discover these previously unknown species and work with the people in the government agencies, particularly the Department of Environment and Natural Resources, and tell them about what we're finding and how exciting it is, the response often is, oh, let's make that area into a national park. So this is a complex process. There are lots of things that are involved. I'm sure you can imagine just how complex it is. But what we found is that these discoveries do often either provide a spark or they contribute to some pre-existing spark for declaring protected areas. So the work that we have done now, here's a list of the new species of mammals that we have discovered in these areas, and the parks that either have been declared or positively impacted or are in the process of being declared as a result of this work. Basic discoveries about biological diversity can make a huge difference, especially in areas where there has been little research done in the past. Part of the work, of course, has been done in the context of helping Philippine biologists develop their capacity to do this work. Programs in the field, we found that classroom in the field kinds of programs where we take a group of students up into the mountains with us for a week or so often is an eye-opening experience. Some of them hate it, many of them love it and stick with it for the rest of their lives. We've also been able to bring a lot of people to Chicago for more intensive and usually more extensive training, the somewhat more professionally advanced people. That also has had a big impact. We have used this as an opportunity to help get people in the Philippines together. So when I started working there was almost no funding. There were very few people doing any kind of wildlife research. In the early 90s, the MacArthur Foundation, which of course is based in Chicago, had a program focused on biodiversity conservation. My colleagues and I got a grant from them, and among the other things that were done, training programs and so on, we had a series of conferences, symposia, in the Philippines for Philippine biologists who previously had been scattered all over the country and either didn't know each other or didn't get along or didn't cooperate anyway. Brought them all together and said, okay, what do you guys want to do? And the result of that was the formation of what was originally called the Wildlife Conservation Society of the Philippines, starting in 1992 with 26 members. Now the Biodiversity Conservation Society of the Philippines. And we get, from that original 26, we can now get 300 or 400 people at every meeting. There are several thousand members. Providing a spark can really make a difference. We've worked with the government agencies and conservation organizations on developing lists of endangered species. That has had a huge impact, recommending particular areas to be protected because of their biological importance. And yeah, all of related kinds of things. So one final story. This is familiar. Mount Pinatubo erupted in June of 1991. Massive eruption. The second largest of the last century. The biggest was in Alaska. Nobody was around. It had relatively little impact. Pinatubo was in a very densely populated country and not far from Manila. The eruption was so massive that the ash that shot up into the upper atmosphere caused the Earth's temperature, the planet's temperature, to decline noticeably for 2 years. Well, there had been a little species of forest mouse, one of the earthworm mice, described from Mount Pinatubo in 1964, I think, by someone from the Smithsonian. No information about them subsequently. What the textbooks on conservation biology would lead us to expect is, well, okay, it's an oceanic island, isolated. It's an animal that apparently has very limited distribution. Its habitat was massively, massively disturbed by this eruption. What are the odds that it survived as a species? This is not good. So our team went back to Pinatubo in 2012, so 21 years after the eruption. And this endemic mouse was the most abundant mammal on the mountain. It was everywhere. These animals have been living in that kind of environment with volcanic eruptions throughout their entire evolutionary existence. Of course they've gotten good at it. So, All right. Yeah. So what I'm trying to do is to create an impression in your minds that, yes, there are huge problems, but it's not necessarily as bad as you think, and it may not be beyond the point of redemption. You know, we have reason to be hopeful. Clearly, people love to learn new things. This is cool stuff. Everybody gets excited about it. We found that the government agencies in the Philippines and international organizations respect peer-reviewed research, solidly based research published in good peer-reviewed journals is taken seriously. It matters. It's hard, takes a long time, but it works. Conservation actions often need a spark. Government agencies need us desperately. They do not have enough people to do all this work themselves. And one of the things that I've found that, has become very apparent is that the way to have an impact on all of these kinds of things is to not just do a 3-year project. Those are great. It's a good place to start. But if you want to really make an impact, it's important to make a long-term commitment and to be part of a community of people who you work with for a long period of time. That's how we get things done. Okay, thank you. There was a question over here, if you want to go ahead with that.
Thank you so much for this talk. I was just wondering, this is all new species. Did we miss some that weren't new? I mean, I didn't see any monkeys. I didn't see different things. What other animals are there?
Yeah, so one of the things that's distinctive about oceanic islands, ones that have never been connected to the mainland, is that they have lots of things there that are unique. But they also are distinctive for lots of things not being there. So one set of islands that are politically part of the Philippines have monkeys and little carnivores that are sort of kind of equivalent to foxes and skunks and badgers and things like that. Various other kinds of things. Squirrels. They're not in the rest of the country. They're just not there. Apparently, they just never got there. The archaeological record shows that among carnivores in particular, there were 2 species of animals that are part of the group that are referred to as civets that were introduced by people about 4,000 years ago. And they're naturalized at this point. They're pretty widespread. They're not native. There are no native mammalian carnivores in the Philippines, with the exception of this one little island group.
How did the Second World War affect the animals in the Philippines?
Yeah. Well, obviously the history of World War II in the Philippines is major. It's very complex. During the war itself, there was essentially almost no logging that went on, almost no agricultural expansion that went on. During the war itself, probably with the exception of animals that are big enough for soldiers to hunt, pig and wild pigs, native species of pigs, and deer, which were hunted heavily. Everything else was pretty much left alone because people were hunkered down and trying to keep out of trouble. After the war, things changed dramatically. So the Philippines very quickly developed the strongest economy in Southeast Asia, and in fact, at one point, we're ahead of Japan. That economic expansion had a lot of positive aspects to it. But Immediately after the war, logging started up in a big way again. Dole pineapple, for example, moved in and cleared areas and converted lots and lots of lowland forest areas to production of pineapple. So the end of the war and the things that took place associated with the end had a more negative impact on the environment than the war itself did.
I was intrigued by a bat that was on the first slide. It was a furry bat with gigantic ears, and it was on a couple other slides too. What can you tell me about that bat?
So the very, very first one?
Yeah, it was on the right.
Yeah. So that was something that Judy and others put together. So that animal it's a tarsier. It's a tiny little primate. Tarsier is the English name. They're related to lorises and other sorts of things. They're active at night. They have those huge eyes so that they can see insects, which is what they prey on. They leap from one typically skinny little pole-sized tree or, sapling, something of the sort, to another, chasing after frogs and insects and things of that sort. That's the one exception to the primate story. So that one species managed to make it into the Philippines from Borneo, but only into Greater Mindanao. They're really cute little animals. Yeah, they're great. We've seen them a number of times. You're out at night checking nets when you're trying to catch bats, and there's this thing with eye shine looking back at you. So this is the tarsier.
The primate, no.
Yes, that's a primate.
Yeah,
Yep, okay. You're talking about one of the bats?
yes.
Yeah.
The one on the right.
Yeah. So, that structure that's inside the ears
Right.
there is, the technical name is tragus. So it's sort of like the little dumaflachi that you have in your ear, except that it's very long.
Yeah.
That's involved in the echolocation system. It's as the sound comes in, there's a certain amount of it that's, echoed around inside the external ear, and it influences the perception of sound.
It's just so interesting,
Yeah.
all the different characteristics of all these, too. And that you found all these. Thank you. It was a very good program.
Well, thank you. Yeah, the bats are fabulous. I could easily have gone on for a couple more hours.